Hello. Thanks everyone for joining today's meeting. We are doing a presentation for Gradle 8.5 and 8.6 releases. 2 weeks ago, we released the 8.6, so it was a feature-packed release with many things. And before that, we also had 8.5, for which we skipped the presentation. So today we decided to do this presentation together. So effectively, you get an update from November 1st until today. And as you can imagine, there will be quite a lot of changes we want to present today. So thanks everyone for doing this presentation. First of all, I want to say thanks to all the contributors. We had 18 contributors for 8.5, even more for 8.6. And these are just contributions to Gradle Build Tool. There were more contributions to the ecosystem, to compatibility, issue reporters. So in fact, thanks everyone who participated, who shared their feedback about release candidates, etc. We appreciate that a lot. What we are going to discuss today, of course, we have a few big features to report on. Java 21 support, of course, it's now LTS release, Kotlin DSL, built initialization scripts, wrapper updates, configuration cache, and a few other things. So you can see everything on the slide. And actually, this is what we are going to present today. So without spending too much time on the introductions, let's just go forward. And the first one, Java 21, and I believe Octavia will present. So let me click the button.
Gradle now has full Java 21 support. This means that you can run Gradle on Java 21 as opposed to before where you could only compile and test using tool chains. However, you may need to update some of your dependencies in your own project in order to take full advantage of this.
Yeah, thanks. And the next one was Kotlin DSL improvements. And for that, it will be Paul who presents, right? Okay.
Hello, everyone. So yes, in Gradle 8.5, we made a few improvements to the Kotlin DSL. And the first one is about its performance. It's faster on first use. Like when you start from a new machine, when you run on a CI ephemeral agent, for example. We do less work when starting the Kotlin DSL, and this graph example shows a single project build with a couple scripts running the help task, and it shows 4 seconds shaved from the first use, which is very much welcome. I said this doesn't happen every time. It only happens when Gradle starts. And the explanation for these seconds shaved is that previously we were generating some Kotlin code and compiling it on first use. And now we do that when we build the Gradle distribution instead, so that our users don't have to do it anymore. Next slide. The second improvement we made to the Kotlin DSL is to provide convenient access to the version catalog API in precompiled scripts. And this allows to, it's different from the accessors, static accessors to version catalog. The version catalog accessor provide the type unsafe API, meaning that you address version catalogs and entries using strings. And it allows you to conditionally declare dependency defined in a version catalog if it's present. It was something missing and quite requested by the community. And the last one is not so much user-facing, but it's about using the Gradle Kotlin DSL with Kotlin libraries compiled with more recent version of Kotlin than the one built in Gradle. In previous versions, we disabled a version check built in the Kotlin compiler. And we will change that in the future because it leads to hard to troubleshoot errors. And and we will change the default in the next Gradle versions. We will deprecate skipping that check soon. Starting with Gradle 9, it will be enabled by default. And in the next slide, we show you how to opt into the future-proof behavior starting today. And that's it for the Kotlin DSL improvements.
Okay, thank you for the summary. And the next topic is something everyone likes. I mean, errors and actually troubleshooting and error propagation. So we have a quick update, and let me launch it.
Gradle creates certain configurations using a check if needed strategy, where it will only create a new configuration instance if a configuration with that name doesn't already exist. If one does exist, then Gradle will make use of the existing configuration. Default and archives are two specific examples, but this applies to other configurations as well. Configurations with these names could already exist if your project applied a plugin that created them eagerly, ahead of applying the core Gradle plugins that would normally create them. This problem is a consequence of configurations living in a globally accessible container without using any sort of namespace, which is something that we do want to address in the future. But in the present, creating configurations like this that anticipate the names of something that a core plugin will create can lead to trouble. You could have set a different set of allowed usages than Gradle is expecting. So now when Gradle sees that you have already created a configuration that it expects to be creating itself, and the usage differs, it will warn you about this situation, tell you exactly how its expectations are misaligned with what exists in your project.
Yeah, and actually we have even more improvements for propagation. And the next one is about mutating configurations, so especially important for configuration cache and others.
But warning alone is not enough here. Gradle needs these configurations to allow the usage it expects in order for its own core plugins to continue to work properly. So Gradle will next automatically attempt to mutate the usage of that configuration. But this could fail if the configuration has already been locked against mutation, perhaps by being resolved. Even if this mutation succeeds, a deprecation warning is still shown, advising the use of a different name. The end result of these changes is that now, instead of unexpectedly failing somewhere down the line, Gradle will now walk the author through the situation it encountered, why the situation is a potential problem, what Gradle is going to do automatically to try and work through that problem, and what the author should do in any case to avoid this situation in the future. One more thing, we've gotten some questions about what names are reserved. There is an incomplete list available at the link below. It's necessarily incomplete because configuration names are built from source set names, and we can't anticipate every source set that a project's collection of plugins might create.
Yeah, speaking of that, you can see the link to the presentation in the footnotes. So all the links are available there. And yeah, thanks for the update. And the next one is better diagnostics.
Yeah, that's me again.
Okay.
So yeah, when we made some improvements in the diagnostics we report when Gradle fails to delete files. For example, on Windows, it's well known that files opened by another process cannot be deleted. Another thing that can happen is you invoke Gradle and Gradle tries to delete a directory, but another process is still writing to that directory. All those cases are hard to troubleshoot, and so we paid special attention to building quite comprehensive error messages in those cases. And so we will report all the files that will fail to be deleted. We will report separately the files that will have appeared in the directory we want to delete during the deletion, and that will be a sign of another concurrent process writing to the same directory. And finally, the root cause of all exceptions happening during deletion will be attached to the stack traces, so it's easier to debug.
Thank you. And the next one is about the assertion mappings. Is it also you, Paul?
No, it's me.
But okay.
Hey, hi. So In 8.5, we improved on assertion mapping. This feature was improved in 8.4. Basically, what assertion mapping does is that when you run a test and you have a failing assertion, you get an exception, and we basically process this. It can have a very varying structure. We try to unify it, and through the tooling API, we communicate it with the IDEs, so they don't need to parse any message up. They will have a nice structured message. In 8.4, we made a great improvement. We welcome now a large variety of exceptions, but we made an error in the assumption that when we receive an assertion error, then basically our job is done, and we wouldn't need to do anything else. So in the next slide, we would have an example of this, that you can see that you have an assertion and you wrap it. And we were told that this is not an unimaginable use case, that an assertion is wrapped in another assertion, and you can see in the imaginary structure, the data below, that this is not getting processed. It should say that the expectation was what we expected is 1, the actual is 2, but there is none. So in 8.5, we fixed that, and in the next slide, if you go there, please, for the same use case, now you see the expected and the actual values, and this works to basically to multiple whatever depths you need for multiple categories of assertions. So now the IDEs hopefully could show you immediately a better representation of a failure.
Yeah, that's for sure. Thank you. And yeah, next section is about built init improvements. So, Louis, the stage is yours.
Yep. Okay, thanks a lot. So for build init improvements, one thing that was done first is the usage of version catalog. So far, up to Gradle 8.4 included, when you generated a build, we would not use version catalog. You would have the template dependencies that are declared in the template projects appear as coordinates in the build files. With Gradle 8.5, we replace that by a usage of the catalog, and you see here an example of the catalog that is generated for, I think that's the library example. And effectively then, your build files uses that catalog. Version catalogs were stabilized in Gradle 8, and so it was about time to have the feature inside supported inside build init. And that's
Thank you. And the next one is actually another video about the Java parameter. And we have just 2 videos on this slide. So the first one is how it actually looks. So thanks a lot for this summary. So basically you pass a version parameter, and there you can actually see quite a lot of things. And let's learn more.
Previously, when running Gradle init with an application type that required you to specify a JDK version, there was no way to avoid dropping into interactive mode. Now you can specify a version of the JDK to use ahead of time using the Java version command line argument. If you provide all other required information in the same way, you can now create your project fully non-interactively.
Yeah, thanks for the summary. So basically, this is what you've seen on this video. Thank you. So in addition to initialization, we also have some updates in wrapper improvements. It's Anza.
Yeah. Yeah, so wrapper jar got a bit thinner. Its size now went from around 63 kilobytes to around 43 kilobytes. Basically, what we do, we now remove any unused code via tree shaking live process. So yeah, that's kind of cool. Thanks for thumbs ups. And yeah, wrapper jar now also contains license. So Apache 2 license in the metainf license file. This might be helpful since wrapper jar is often part of users' code base, and users often want to know what is the actual license of the jar, and now it's a bit easier to find it out. So yeah, that's it.
Yeah, thank you. So And next, build authoring. Once you have everything initialized, once you have wrapper running, so you actually start development, right? And who's doing this part? You, Louis?
I'm doing, yep, some of it at least.
Mm-hmm.
So the first thing that was done is when you use catalog, version catalogs, we generate accessors. And accessors had some Javadoc, but it was limited. And one of the things that was not present in the Javadoc was an indication for a library or a plugin of the version that the accessor points at. And so we know effectively include that information in the Javadoc, and you can either have the version itself or the information that the accessor uses a version reference, and then you would find the exact version in the Javadoc of that version reference, or the fact that no version has been defined, since there are ways to define both plugins and library entries in a version catalog without a version. For example, when you leverage platforms or things like that. In addition, we expanded the access to the CopySpec. CopySpec could be obtained for a long time in Gradle from the project object. But as you all know, with the configuration cache, accessing the project object at task execution time or inside a worker is not possible. And so what we did was offer an API on the file system operations, which is a service that you can inject in your custom task type or your workers, on which you can get a CopySpec. And that means you can configure that CopySpec and use it for any kind of file processing, like copying things around with excludes rules and stuff like that. And so mostly this is worker-oriented or configuration cache compatible for task execution. And that's it. And then I think we jump to Rafael for the
Yes, so the next is about build to light locations.
Plugin authors are used to rely on project layout to access project-based locations from their build scripts and project plugins. That object gives you access to the project root directory, the project build directory, and allows you to obtain lazy or provider-based file system locations that are project-based. In Gradle 8.5, we introduced settings get layout. This object is available to settings scripts and plugins and can be used to access build-wide locations, such as the root project directory or the directory holding the settings file.
So, yeah, basically it's what is summarized on the slide. And thanks for the summary. And the next one we have is about build features API that actually provides some additional information about locations of items, etc. So let me start it.
Build features API is the new API in Gradle 8.5 that provides build and plugin authors better insight into what Gradle features are used in the particular build. It aims to replace start parameters, switches, and provides much more detailed view. So far, we only support providing status of the configuration cache and isolated projects, but more can be added in the coming versions. For each build feature, you can see if it was requested and if it was active, which is not the same thing. Requested is a three-state switch. It can be true or false if the user explicitly enabled or disabled the feature, or it can be unset if the user expressed no particular desire. So the feature basically remains in its default value. Another provider available is if the feature was active, and this basically means it's true if the feature is enabled, is working in the build, and false if it doesn't. For example, if we look at a build with the default values, configuration cache is not requested and therefore not active, and the same applies to the isolated project. If we explicitly request configuration cache, we see that it was requested and active, and isolated projects are not enabled. So, and nobody requests them. However, if we explicitly disable configuration cache, we see it's not requested, and there is set false value, it's not active because it is disabled, and isolated projects were not requested and not active. If you explicitly enable isolated projects, you see that the configuration cache is not requested but active, because isolated projects require configuration cache to work, and the isolated projects are requested and active as well.
The next is dependency verification. So who is presenting?
That's me again. So the first thing we've done is, since its addition to Gradle, you could export a keyring of the PGP signing keys for the dependencies you're trusting. But that keyring initially was only a binary format. Then we added an ASCII armored format. Can you go to the next slide, please, Oleg? What happened is that whenever you generated a dependency verification configuration or you exported it, it would generate both files. But then upon using those files, it would always favor the binary file over the armored one. So what we've done in Gradle 8.5 is we've given you the ability to configure which of the two formats you want to use, binary or armored. And when you do that, then the generation will only generate that format. And upon use, like when dependency verification is used to validate the dependencies of a build, only the keyring matching the requested format will be read. So the other one is ignored even if it's present on disk. This was actually one of the biggest source of confusion when doing dependency verification upgrade on the Gradle build by Gradle engineers. So this is a feature that we know will be useful for the folks that have adopted dependency verification. The other thing we've done is change the way we handle key IDs in dependency verification generation, and actually when validating. Key IDs used to be case sensitive, which made no sense because in practice for PGP they're not. So there are no properly case insensitive. And we also generate the key IDs in uppercase in the dependency verification file to match what can be found then in the armored keyring. One consequence of that, of course, is that if you have an existing dependency verification file and you use the generation process to update it, it will report a lot more changes because all your key IDs will be changed to be uppercase for both trusted keys and GPG nodes inside trusted artifact.
Mm-hmm.
That's it.
And that's it, but you also have two other slides to present, Louis. And the next one is about all other improvements.
Yes. So yeah, so some minor improvements that don't really have a category. One of them is inside CopySpec, copy task and sync tasks. The paths that were used were not necessarily canonicalized, and that caused sometimes hard to understand problems. And nowadays, we make sure that paths are always canonicalized, which means dot is no longer used anywhere, and dot will only appear at the beginning of a path to indicate that you're walking up the tree. And so, for example, in the snippet you see there below, that into dot from source dir prior to 8.5 would just do nothing. But because you said dot, so it should apply to the same parent directory which dest is, but actually it just did nothing. With 8.5 on, it will actually copy the stuff into that destination directory from the source you indicated. And then the next one is EAR plugin improvement. Yes, there are still users of the Java EE specification building EAR files. And for a long while, Gradle was lagging behind in the supported deployment descriptor. And so support was added for Java EE8, Jakarta EE9, and Jakarta EE10 deployment descriptors. And so you can now configure them based on a version simply. Previously, you could still use the EAR plugin, but you had to effectively do a full custom deployment descriptor. And now you have a nicer way to specify that.
Yeah, that's nice. Thank you. And basically, that's it for Gradle 8.5. So the release we had in late November. But after that, we started working on Gradle 8.6, and it was released 2 weeks ago. So we want to do some updates just for this release. If you haven't updated yet, please do so. There is a lot of big changes, and the first, of course, is configuration cache. Are you going to present it, Rafael?
The configuration cache was promoted
yes.
to stable in Gradle 8.1. And since that release, the data that's stored by the configuration cache is encrypted because it may contain sensitive data such as credentials. By default, Gradle auto-generates an internal encryption key, which is stored in the Gradle home directory. That's good because the user does not need to bother with creating encryption keys. However, that can be problematic in some cases, such as ephemeral CI environments, where you may want to share the configuration cache area among different machines. The internal encryption key managed by Gradle is not meant to be shared. In Gradle 8.6, we added support for custom encryption keys. When a custom encryption key is provided by the user, Gradle will use it instead of generating one. The way you tell Gradle to use a custom encryption key is by setting the Gradle encryption key environment variable. The key must be a valid AES key, encoded as a base 64 string.
Okay, thanks for the summary. And then we also have built-in initialization and auto-rank improvements. So same as in 8.5, we also have quite a lot of updates in those sections. And for building it, are you presenting, Louis?
Yep, me again.
Okay.
One change that was made in Gradle 8.6 is about the default source package. Gradle used to derivate a package name based off the folder in which you were generating your project, which made little sense. So we decided to replace that with an org.example package name always, if you do not specify anything, which means that effectively the interactive question about the package name has disappeared. However, you can configure the package name on the CLI with the -- package option. Or you can also set a default value in Gradle.properties. And so let's say in my organization, we want to use my.corp.domain always as the package name. I can put our Gradle build init source package in my Gradle properties, and then it will all, like any project generated with Gradle init will use that. We did more changes to Gradle init though. The first one is actually finding out a way to skip all the interactive questions. And that's done by using the use defaults CLI flag. What that flag does is that it will respect any other build init flags that are present on the CLI. But for all the others, instead of asking you an interactive question, it will use the default for those questions. And so an example of that is, let's say I want to generate a Kotlin library, but for the rest, I'm happy with the default, like default Kotlin DSL, default Java version, all of this information. I can just do Gradle init use defaults type Kotlin library, and I will have a fully non-interactive init generation. And then one thing that was made available in past versions of Gradle was the assignment syntax in the Kotlin DSL. So the ability to set the value of a property by just having a value of the wrapped property type on the right-hand side. And now this feature is used by build init. And so we see an example here when we generate an application. It has a main class. The main class is a property string. And so we can see that now we can immediately assign a string to that property string. We don't have to do a main class .set as was done in previous version. And that's it for the build init.
Okay, so the next one is about build auto rank, and I guess Joseph wanted to present filtering of collections. Okay.
In Gradle 8.6, we have added a new filtering method to name domain object collections called named. Its advantage is that it filters the collection elements just based on their names without touching the entire element. The benefit of that is that it doesn't trigger the realization of lazy element types.
Okay, so yeah, this is one of the features we had, and another one is from Octavia about using providers with dependency capabilities, so that you get more flexibility how you define dependencies and sources.
Gradle now supports passing a provider for the value of capability. All existing types that could be passed down before are allowed to be returned from this provider. This allows you to delay the resolution of their value until the capability is actually needed.
Yeah, that's pretty cool. And also all other forms of providers also work. So, okay, and the next section, as before, is actually error propagation and reporting. So who is presenting?
Yep.
Aloy.
When leveraging dependency locking and when you got an error about either a corrupted log file or things like that, the error message would mix both the statement, like what was wrong, and would also contain some hints about what to do. So what was done in a previous release was make the message much clearer, and that was actually contributed by the community. But what was the reason we're mentioning it only now in 8.6 is that we also worked on splitting the error itself from what needs to be done. And so you can see here the what went wrong, and you see the root cause is an invalid load state because we have a line which clearly indicates that somebody did not resolve a merge conflict. But that's the error. And then under the try section, we can see that you should verify the log file content for more information on format, and then we link to the documentation, which gives you a more structured way of handling this kind of errors.
Thank you. And the next one is about circular references. Everyone likes circular dependencies, references, and everything that kills your call stack. And let's see how you can troubleshoot it now.
When working with the lazy Gradle configuration APIs, such as properties, it's not that hard to introduce an accidental circular evaluation. You start with the property, you apply some map, flat map, and other calls to it, and you end up with a provider that you accidentally assign as a value to the property itself. This circle cannot be easily evaluated, and prior to Gradle 8.6, what you get was a dreaded Stack Overflow error, which is not particularly helpful when you try to debug it. Starting with Gradle 8.6, we produce a slightly more useful error message that shows you what went wrong and what was the actual circle evaluation chain. And then you can use the stack trace to find out what the user code is being called and where the circle evaluation comes from. It's still not perfect, but definitely better than it was before.
As somebody who just fell into this issue a few weeks ago, I really appreciate this patch. Thank you. And the last section about IDE integrations and improvements. And we have a summary from Donut about Problems API and other features that are being introduced there. Let me play it.
Okay, let's talk about the Problems API. The Problems API enables plugin and build engineers to report rich, structured information about problems that may occur during the build. In Gradle 8.6, we added an incubating API to report and consume problems. The Problem Report API is available as a standard Gradle service. You can report problems with sufficient details, including the message, severity, advice on how to solve the problem, location data, and more. The service can be used in plugins, displayed in the sample on the slide, but it can be also used in build scripts as well. Problems can be consumed via the tooling API. The reports are exposed as progress events that clients can subscribe to. Regarding integrations, we changed several Gradle components to report errors and warnings via the Problems API. This includes, but not limited to, version catalog errors, deprecation warnings, test validation warnings. As for the consumer side, we have a working build chip feature to consume problems and convert them to error markers on the UI. We are also coordinating with maintainers of major IDEs, such as Android Studio, IntelliJ IDEA, and Visual Studio Code to add similar integrations. As a follow-up project, we are working on adding integration with Java compiler warnings and more. We want to have those reports to enable better IDE integration, to enable build scans, to consume and render compiler warnings on the dashboard, and to use the reports to improve the compilation messages on the console. That's all. Thank you.
Thanks, Donat.
And let's briefly discuss the documentation updates.
In Gradle 8.6, we supercharged the user manual's running Gradle builds section. It's been revamped to include core concepts and a tutorial, guiding users from the basics of using the Gradle wrapper all the way to applying plugins. This section has everything you need to kickstart your journey with Gradle. The Authoring Gradle builds section, which covers topics for build engineers and plugin authors, has a new Learning the Basics chapter, and it focuses on writing custom tests and plugins. And then the tutorial puts all of these learnings into practice. Finally, the new Structuring Builds chapter has been updated with best practices for creating new Gradle projects.
And actually, that's all. So this is what we wanted to present today for 8.6 and 8.7. So if you have any questions, please join us on the community channels. So we have Gradle Slack, we have Gradle forums. There we can discuss everything, and any feedback will be welcome. Also, by the time you watch this video, most likely 8.7 release candidates will be available. And again, you can try them out, share feedback. But one thing we ask you for sure is updating to 8.6 and trying out all these new features we presented today. And again, if you experience any obstacles, please let us know, and see you next month or maybe in 2 months with the next release.